somebody can look at it and go,
It looks like it came from Subway. That's what they keep the mayonnaise in.
exactly, neat.
It's not exactly what it is.
No, that's how a lot of people would look at that, right? Because it's just another part.
Yeah.
When I look at it,
Wouldn't be on this table if there wasn't something very significant about it.
well, when you first asked me that, you saw my reaction, right?
Yeah,
What's
you got
significant
really
about that?
excited.
Well, I mean, because how complex to build something like this with such tight tolerance in a deep draw form like this, right? I mean, this is like magic, And when you come from subtractive type of world, right, where we're taking a big block of material and we're machining it down into something like this, you can see it pretty easily, at least, the way I'm wired. You can see that pretty easily in your mind about how you would go about doing that. This deep draw, there's a series of different ways to go about doing it. Whether it's a straight hydroform press, sometimes depending on the shape and the tolerance and the depth and the radii that's involved in this, in order for this material, because this starts out as just a flat sheet of material, and then it gets pressed into this shape, formed into this shape. And to be able to see the tools in your mind, again, when you come from this industry, that isn't that complicated, but to get a final net result with all these tight tolerances and having all of the tolerances met based on all of these different surfaces that all have to flow together, at all these different rates. And you asked a really interesting question about basically the material thickness, right? Is this thickness the same as this thickness?
No.
Yeah, because at some level, the material has to stretch from somewhere to get into that shape, right? So that's all part of the engineering of the tooling side, which is you need to be able to hold the material in such a way that the material is going to, I'll say, let's say just in simple terms that you have a female die that's the bottom of this and it's the perfect shape, and then you have a male die, and I'm just using this as an example, because sometimes in these we do a combination of multiple tools that will hit this to get this shaped into the right part. Sometimes we'll build, depending on the material and the condition of the heat treat of the material, the hardness of the material, we will have it in a very specific condition, meaning that it's in a soft state. All the molecules are aligned just in the perfect way because we send it out to heat treat and then it takes it into a certain condition, like this is probably an O, and then we form it, and then when it comes out of the form, we send it back. And depending on whether it's coming or going, if it goes out to heat treat and holds in this certain condition, we'll bring it back on ice. So the part's literally iced. And then we'll run through a series of tools that will push it into this form. And depending again on what we're doing, there's all kinds of very specific process rules, we'll call them, that will hold that material in its state so it can go into the next level of either forming and or heat treat, so it can get into its hardened condition, and then we would process the rest of the part, right? Meaning, like this part will actually get machined off down to the shape of the finished part. This is all just excess on what we have to hold on to control the shape. And you can see how the material, as it's being formed, it has to actually go into, the material has to go somewhere, right? So you can see how it gets swaged down into these particular, but we pre-engineer all of that into it because we know what the net part is going to be. And that's why when you have really smart people that know how to do this, which is subtractive machining, to develop this type of tool in many ways is a completely different mindset, right? Because not in the sense of processes of machining, but in the processes of forming, right? So what kind of condition the material needs to be in, how do we need to hold on to the raw material and hit it its first time, meaning shape it and form it into a rough shape. Because if we have to maintain the thickness of this material, which we do all the way around, we got to make sure that it's stretching the material in the right place in the very beginning to go hit it potentially a second or third or fourth time in order for us to can maintain wall thickness all around that part. So, so seemingly, hey, it's no big deal, just look at that thing, right? But the amount of engineering and know-how and sort of this is where the science sort of crosses over into art, on knowing how to hold on to the material, process it through a series of form tools to get it into that shape while still holding consistency in the wall thickness all around in order to meet the customer spec.
There are a lot of radii,
Yeah, all those blended surfaces to come together.
different vertices. Look at that. There's
Yeah, to
1, 2,
maintain.
3. Like, look at all of them, right to these two,
Yeah, yeah. And
and at the bottom of the pole.
yeah, and so that's where like the magic comes in of having, these super talented people that have experienced all kinds of various levels of forming, and then getting, like you think it's going to go a certain way, so you build the tool, you engineer it in a certain way, and then you go and hit the thing, and you're like, man, that thing just is a mess, right? Didn't do anything that I wanted it to do, and so, over time, you learn. Ideally, you'd love to be able to build one set of tools, hit the thing, and it's done, right?
Yeah.
But the reality is that rarely works that way.
Yeah.
When you have these really complex, deeper draws like this with very, very tight tolerance and that combination of, as you were just pointing out, right, of all these radii coming together, and then maintaining the material thicknesses all throughout all of those as well, right?
I mean, just in this little tiny area.
Yeah, just like in these areas, that material had to go somewhere, right? Same here. Fortunately, here we're actually forcing and stretching the material back, and then it all has to be controlled, because if I have a tool in a certain shape, it's going to pull the material more from the big flat surface.
Right.
If I have the tool in another pre-programmed engineered state, then we want to evenly pull the material from the sides and the bottom so we can maintain wall thickness all throughout. And there's all kinds of variations of, that's kind of where our little secret sauce in certain areas, little magic that we, little pixie dust that we sprinkle on, to get some of this stuff to happen. And we're gonna, as we're going through in this series, we're gonna actually show people, like some of this stuff and how we do it. And there's going to be areas where we are going to maintain our very specific IP or intellectual property, where we think it's appropriate, and everywhere else that we believe is basically like commoditized in operations and ideas, then we're just going to teach everybody how we do pretty much everything, because I think it's important. It's more important to expand the base of manufacturing in the United States than it is for us to just maintain our own little tiny corner of the world, when you realize that we are so under capacity when it comes to spindles in the United States, or just machines and or talent that can operate all the robotics and the tools and all those kind of things, that I think it's more important for the expansion of the manufacturing industry, and most importantly, the sovereignty of the United States, is that we need to have people that become masters in forming and shaping materials and machining materials into so many of the, we call them super components, that get stacked up into anything that, flies, transports, surveils, and in some cases even kills you, right?
Yeah.
All of the tools that are required to maintain a sovereign nation and high quality of life. So thanks for that question. I love things like this because they're somebody can look at it and go,
It looks like it came from Subway. That's what they keep the mayonnaise in.
exactly, neat.
It's not exactly what it is.
No, it becomes very, very complex on every aspect of the manufacturing process, and it takes super talents to do this really well, really effectively, and efficiently.